Hi everyone. This video is going to be about rational exponents. It's a fancy way of saying exponents that are fractions. We've talked about positive integer exponents, negative integer exponents, and the power of 0. But now we're going to talk about what it means to have a fraction as an exponent. So let's take a look at an example that will get us a little further along to understanding what it means to have a fraction as an exponent. If I say x to the 1/2 power, let's take the simplest fraction there, and I square x to the 1/2 power, we know that using our power of a power property that we multiply these two exponents. And when I multiply 1/2 times 2, I hope you know that that equals 1. So x to the 1/2 power squared is x to the first, which is x. So we can probably get a handle on what x to the 1/2 is if we can figure out what squared gives us x. So let's talk about that. What squared gives us, let's say, 9? Well, that would be 3, wouldn't it? What squared gives us 49? That would be 7, wouldn't it? So if I say what squared gives us x, then I hope you can see that this number here, to get from there to there, don't we square root? We sure do. So the square root of x squared is x. So if we know that x to the 1/2 squared equals x, and we know that the square root of x squared is x, that must mean x to the 1/2 power equals the square root of x. So when I take something to the 1/2 power, I'm actually square rooting it. For example, if I were to say 81 to the 1/2 power, that would be 9. That's square root of 81. The 1/2 power is the same as the square root. Now what if we had x to the 1/3? I would hope you'd be able to see that if we raise that to the 3rd power, we also get x. So what times itself 3 times gives you x? The cube root of x. The cube root simply means, that's how we write it, what times itself 3 times gives you x. For example, if I have the cube root of 8, I know I can write 8 as 2 times 2 times 2. So what times itself 3 times gives us 8? 2. In the same way that we talk about the square root, say, of 4, which is 2 times 2, and we say what times itself twice, or what times itself gives us that number under the radical sign, and that's 2. And you can also have 4th roots and 5th roots and so on. So I think you can see that what we've got here is when we talk about x to the 1 over a number, we'll call it a, that is the same thing as the 8th root of that x. That's an a. Let me erase that and write that a little better for you. Get that out of there. This is the 8th root of x. Okay, we can write that as a rule. It's a pretty good rule to write. You will notice, however, that when we do the 1/2 power, we don't write a 2. Do it in a different color. We don't write a 2 in here. The 2 in a square root is understood, so there's no need to write it. In fact, you shouldn't write it. Okay, the square root is automatically has this 2 as a root. It tells us how many copies or how many times we need to multiply something by itself to get that number under the radical sign. So here's our rule. So if I say what is, let's see, y to the 1/5 power, we'd say that that is the 5th root of y. Pretty simple. I hope so. We have a little bit of an issue, though, when it comes to multiple things that are under the radical. Let me move this up here a little bit. Okay, if we have, let's say we have this. What if we have 2x to to the 1/3 power. Well, I can say that's the cube root of 2x. But if I wrote 2x to the 1/3, that 1/3 power there is only referring to the x. So if I were to write this in radical form, I would leave the 2 outside the radical since it's not being raised to the 1/3 power, only the x is. This actually is more of an issue when you start going the other way, when you start going from radical form to fraction exponent form. Let's do one or two of those. What if I said I had, that's not what I meant to do. What if I said I had the, let's say the 6th root of 5n. 5n to the 1/6, right? Nope. Because if I write 5n to the 1/6 like this, that means that this 1/6 power is referring only to the n, and that's not what we mean. We mean that the entire 5n expression is raised to the 1/6 power, so we need to put it in parentheses. So be aware that any time you write something to a fraction power, or to any power for that matter, and you want that power to refer to all of the terms, you need to put it in parentheses. Okay? The other thing I want to say about this particular form of a rational expression, or rational exponent I should say, is what if it's negative? What if I say, what is x to the negative 1/2 power? Well, let's talk about what we learned about negative exponents. Didn't we learn that a negative exponent is simply the reciprocal of the positive exponent? And if you need a little refresher on that, there's an earlier video on negative exponents that you can watch. So it should make sense to you then that this is 1 over x to the 1/2, okay? Which could be written as 1 over the square root of x. And remember, we don't write the 2 in the radical sign there. Okay? So if we want to write another rule here that's related to the first one that I wrote, how about we write x to the negative 1 over a equals 1 over the 8th root of x. Which begs the question, folks, I'm sure you've had the question, what happens if the numerator of our fraction isn't 1? Well, let's talk about it. What does it mean to have x to the 3/2 power? Well, not terribly complicated. All we need to do is rewrite it as x to the 1/2 to the 3rd. Is it 1/2 times 3? 3/2. Sure is. So what have we got? We've got the square root of x, that's x to the 1/2, to the 3rd power. Turns out we can also write that like this. We're not going to talk about y until we get to radicals in a later video, next unit in fact. But for now, you just need to know that you can still see it written either way. Okay? So we'll write a rule here, and that rule is this. X to the b over a, and I'll keep the a on the bottom to match our earlier rules, is the 8th root of x raised to the b power. Or, as I mentioned, you could also write this the 8th root of x to the b. That power, this b, can either be outside the radical or inside the radical. They're both equal. So the denominator of my fraction exponent gives us the root, and my numerator gives us the power. Pretty straightforward. Once you get the rule, it's not that terribly difficult, I hope. Let's do a couple more problems, and then we'll be all done with this topic. All right, so what if I have, let's see, what if I have 7c to the 4/5 power? Okay, the denominator is our root, that's 5, the 5th root of 7c, and I'm going to put all of 7c under the parenthesis, inside the radical, excuse me, because it's all in parentheses there. And then we're going to raise that entire thing to the 4th power. Or we can write it, and you'll see it written either way, 7c to the 4th. Okay? What about negatives? What if I have, let's see, what if I have 3n to the negative 7/6? Well, that's 1 over 3n to the 7/6. 1 over, what goes here? What goes in the radical? The denominator, 6. 3n raised to the numerator, which is 7. Or again, we could rewrite it this way. 6th root of 3n in parentheses raised to the 7th. Either way is acceptable. Okay? And make sure you can go the other way as well. Make sure that if you're given a radical, you can also write as a fraction exponent. For example, if I were to write, say, 10y, and we're going to take the 4th root of 10y raised to the 9th power. Okay? We're going to say 10y. My denominator is my root, that's 4. And my numerator is my power, that's 9. And because the entire 10y is in the parentheses, I'm going to put it in parentheses. Under the radical, we're going to put that in parentheses. If I had written this instead, I could even put the power inside. That would be 10y to the 9/4, and we wouldn't put it in parentheses because the only thing being raised to that power, the only thing under the radical is the y. I think one more should do it. How about 1 over the square root of 4z to the 5th power? Okay? So what have we got? We've got 4z. It's in parentheses because the entire thing's under the radical. It's a negative exponent because it's a reciprocal. My denominator is a 2, that understood 2 that's in square roots, 2, and my numerator is 5. There you go. So I think that's what you need to know about fraction exponents. Next up, we're going to do some simplifying of these fraction exponents. Thanks.